Okay, welcome back, Unit 5, Session 2. So we've already discovered that TRIZ is considering design conflicts and the commonality that it has with QFD. We know that design principles could be applied. These are called inventive principles within the TRIZ language, and there's 40 of them that we might consider. Now, I'm not going to look at all 40 of these, but I'll look at a few. The first one here, for example, is segmentation. Quite commonly used. Sectional furniture, module computer components, folding wooden ruler, garden hose that can be jointed together to form any length required. So the idea of designing products in modules that can then be reused so that we don't keep on inventing and applying different specific design solutions is quite common. You might take, for example, kitchen design, where we have the same base units, and we might use them for drawer furniture or cupboards. So we might reuse the base unit to make other potential products. Cuts down on cost, cuts down on stock holding, is a good general principle. If we look at some other ones here, asymmetry. So the example that's given, make one side of a tyre stronger than the other to withstand impact with the curb. Yeah, that could be one. There's one here, whilst discharging wet sand through a symmetrical funnel, the sand forms an arch above the opening, causing irregular flow. A funnel which is asymmetric shape eliminates the arching effect. What can happen with a funnel is that as the wet sand in this case is going through the funnel, it can jam where the funnel is symmetrical. But if the funnel is asymmetrical, that is, the output is to one side, then there tends to be less possibility for blockage. So that can work quite well. Go further on. I'm going to pick up here on 31. You'll see why later, but use of porous materials to avoid pumping coolant to a machine. Some of the parts are filled with porous material to soak up the coolant. Coolant evaporates when the machine is working, providing short-term uniform cooling. So use of porous materials could also be where we want high rigidity but reduced weight. So we could increase the diameter, let's say, of a structure, or the eye section of a structure, take out some of the material, i.e. make it porous, and therefore we could reduce the overall weight. So that might be a possibility. I'll go down to 34, rejecting and regenerating parts. What we could do here, what's an example? Rocket booster separates after serving their function. So we don't have, for the rocket, the problem of retaining the whole of the rocket, which would be a problem on landing potentially. So we discharge, separate off the booster, and then we haven't got its weight and its problem when we come to manoeuvring or landing or things of that sort. So that could be used. But also we could consider here having additional components within a design which may or may not be used as required. And I'll come back to that in an example I'm going to come to a little later. 40, composite materials. Military aircraft wings are made of composites of plastic and carbon fibre for high strength and low weight. So this is suggesting that what we could do is, rather than having one material that we use for a particular structure, that structure could be made up of more than one material, and then we get the characteristics perhaps of both. This is an interesting one in car design. These days a car wing, let's say made out of steel, it doesn't need uniform strength throughout its structure. Where the strength is needed most is at the point of fixture, say down the line of the door. What we could do is make a composite panel out of some high strength steel and so some cheaper low strength steel, weld those together to make up a sheet, and then press the car wing out of this composite structure, so that we have the advantages of strength where we need it, but the advantages of low cost where we don't need the strength. You should probably have a look at a few more of these. There's examples for each of them, but I'm now going to go on to session 3, where we'll talk a little bit about application.